Hi folks, Dr. Chapman here. Today we're going to investigate Hawaii Volcanoes National Park and hotspots. Hawaii Volcanoes National Park is located on the Big Island in the Hawaiian island chain. All of the Hawaiian Islands are the tops of giant shield volcanoes that rise from the ocean floor. If you combine the distance from the ocean floor with the elevation of the volcanic peaks, these volcanoes are taller than Mount Everest. The hot basaltic magma that forms shield volcanoes has a relatively low viscosity, meaning that they are more runny and less sticky than other types of magmas.
Ew, they're sticky.
Because of the low viscosity, lavas tend to flow outward for long distances, which results in long, gentle slopes, which is where shield volcanoes get their name. By contrast, ocean island arc volcanoes, like those found on the Aleutian Islands in Alaska, and continental arc volcanoes, like those found in the Cascades in the Pacific Northwest, are formed chiefly from intermediate magma compositions like andesite. More silica-rich magmas are also more viscous, and these lavas don't flow very far from the source after they erupted. As a result, arc volcanoes have very steep slopes.
As you wish.
The high viscosity and water content in arc volcano magmas also makes them much more explosive than shield volcanoes. Giant shield volcanoes like Mauna Loa and Mauna Kea were built by many tens of thousands, perhaps 100,000 individual lava flows, each less than 10 meters thick. The volcanoes were each built in about 1 million years, which is not very long geologically speaking.
Long time ago.
This shows that while they're active, the Hawaiian volcanoes produce an enormous volume of volcanic rock at very rapid rates. Lavas can erupt at the summit of volcanoes, like at the Kilauea crater, but magma also spreads out beneath the volcanoes through deep fracture networks called rift zones. Volcanic rift zones can sometimes be confused with rifts and rift valleys like the Rio Grande Rift. But rifts and rift valleys form by extensional faulting related to tectonic stresses, like when two tectonic plates are diverging.
An interdimensional rift.
Eruptions tend to concentrate along volcanic rift zones, and the intrusion of magma itself helps to create and enhance fractures as the rocks are tilted and uplifted as the magma intrudes. So there's a positive feedback loop between eruptions and rift zone formation. The elongate shape of Mauna Loa is related to the growth of the volcano along two rift zones that extend outward from the central vent. Magmas traveling through these rift zones or other underground plumbing systems
It's me, Mario.
often erupt on the flanks of the volcanoes. The lava can get squeezed out of narrow fissures and form spectacular lava fountains. Or it can erupt from vents and form lava pools or small cinder cones or spatter cones. The Hawaiian Islands and volcanoes formed above a region of hot upwelling mantle called a mantle plume. Mantle plumes usually cause the upper mantle to melt and produce magmas and volcanoes, and so they're often called hotspots. Although it's still debated, hotspots like the Hawaiian hotspot are thought to be more or less stationary.
I swear, I'm not even moving.
The reason there's a chain of islands in Hawaii is because the Pacific Plate is moving over the stationary hotspot. Kauai is an extinct volcano that moved off of the hotspot about 5 million years ago, whereas Kilauea on the Big Island is an active volcano located directly above the hotspot. If we look at the seafloor bathymetry, we can see there are actually many more ancient volcanoes which are located beneath the ocean that extend past Hawaii. These are called the Hawaiian Emperor Seamount Chain. These are old volcanoes that formed when the Pacific Plate was over the hotspot. The oldest volcano in the chain is the 82 million year old Meiji Seamount, although it's possible that there were older seamounts or older volcanoes, but they were subducted into the Kamchatka Trench. The youngest volcano associated with the hotspot is not actually Kilauea, but an underwater volcano called Loihi. Geoscientists think that Loihi will be above sea level and become its own island in about 60,000 years.
You feel its power growing, don't you?
The orientation of the Hawaiian Islands and seamounts tells us which direction the Pacific Plate is moving, to the northwest, and the age of the volcanoes tells us how fast the plate is moving, about 10 centimeters per year. That's not quite as fast as your hair grows. The conspicuous bend in the Hawaiian Emperor Seamount Chain also suggests that there was a change in the direction of plate motion. Volcanic rocks dredged up from the bend in the Seamount Chain are about 47 million years old. 47 million years old.
That's what I said.
So geoscientists know when this plate motion change occurred. Hotspots are one of the main ways geoscientists can determine absolute plate motion. Most of the time, we only consider the relative motion between two tectonic plates. For example, North America is moving westward at about 2 centimeters per year relative to Africa. Once the Hawaiian volcanoes move away from the hotspot and are no longer growing, erosion starts to wear them down and the islands become smaller and eventually disappear beneath the ocean's surface. Wave action often bevels the tops of the old volcanoes, and flat-top seamounts are called guyos. The old volcanoes are also lowered by thermal subsidence. Subsidence is the lowering of the land or seafloor surface. Above the hotspot, the upwelling mantle plume heats up the oceanic lithosphere and it causes it to expand and become less dense, and this rises the overall surface of the seafloor. After a volcano moves off a hotspot, the crust starts to cool down and becomes dense again, causing the lithospheric plate to sink or subside. Another theory is that in addition to heating the lithosphere, the upwelling mantle plume may actually physically push up the lithosphere, called dynamic uplift. At the same time that the old volcanic islands are sinking, coral reef communities are growing around the islands, and the upward growth of coral reefs can keep pace with the sinking of the islands. After the volcano has been eroded or subsided beneath sea level, the coral reefs may remain, which is called an atoll. Like the Midway Islands are part of the Midway Atoll. That was an active volcano of the Hawaiian hotspot about 28 million years ago. And as little as 10 million years from now, Hawaii Volcanoes National Park and the Big Island may form an atoll themselves or completely vanish beneath the waves. So visit while you can. Hey, thanks for watching. Check out some more videos and share them with friends and family. Take care.